All right, hello, this is my Unit 7 video assignment, and today I will be analyzing a problem where there's a computer programmer who is using complex numbers to implement a geometric transformation on the complex plane. So the problem states that the programmer starts with this original square that I graphed in blue right here, and this square is rotated 45 degrees counterclockwise and dilated so that its new vertices lie on the midpoints of the original square. And I graphed that transformed square in red right here. And question A asks, what complex number should the programmer multiply by to produce this transformation? Now, in order to determine this, you need to choose one vertex from the original square and then look at the transformed version of that vertex in order to see what you needed to multiply the original by in order to get that transformed vertex. So right here, I wrote the original vertex 2, 2 in rectangular form right here as 2 plus 2i. And then I transformed that into polar form using these two formulas right here to find out the value for r and theta. And I ended up with 2 rad 2 cis 45 degrees as the polar form of the original vertex. And next, for this transformed vertex, I did the same thing. As you can see, in rectangular form, it is 2i, and in polar form, it is 2i sine of 90 degrees. And after this, I set up an algebraic problem where z1 is the original vertex and z2 is the transformed vertex. And as you can see, I set up z1 times z equals z2. Now we're trying to solve for z, so you divide z2 by z1, and then you plug in the actual values right here. And then the rest I just solved algebraically. Right here I multiplied by the conjugate, and I ended up with z equals 1/2 plus 1/2 I. That's the answer for z in rectangular form. And then in polar form, it's z equals the square root of 1/2 times cis 45 degrees. So that is what the original square needed to be multiplied by in order to get transformed into the new square. Now for part B, it asks, what happens if the original vertices are multiplied by the square of your answer to part A? So first, I just got my answer to part A and squared it, and I ended up with 1/2 I in rectangular form. And next, I tested all the vertices of the original square and multiplied them by the square of my answer to part A, which I just showed was 1/2 I. And I ended up with all these values in rectangular form. I did it all in rectangular form because it was much easier than polar form in this case. And then right here, I put all the original vertices to the original square. And then these are the transformed vertices when you multiply the original vertices by the square to the answer of part A. And I actually went back and graphed it right here on the original graph. I graphed it in pencil. So as you can see, what happens is you basically get a very similar square to the original transformed square in red right here, except by squaring that answer, you actually ended up compressing it by a factor of 2. So yeah, that's about it. Thank you.